Alright, kinematics. Let's continue. This was a generic view of what we went through last time. This time, let's talk about projectile motion. Projectile motion, by its name, is essentially like this, like that. So like a peak, it's thrown at an angle theta. It's not good. Let's draw a better theta. And it goes up, and then it goes down, like that. And what's important about projectile motion is that you're still doing suvat, but you have a horizontal component and a vertical component. Two components. Let's erase that. And they all can be different. However, let's use a better way to visualize this, and so that I find this easier. There's a height, or let's say you can say a cliff. Let's say it's a mountain, okay? And there's a person up here, and he throws a rock down the hill, okay? At, let's say, a horizontal initial velocity of u with a height of h, displacement of d, and what you want to know the question will ask, but some key points to notice is that your vertical and horizontal distance, so annoying, your horizontal distance and your vertical distance, horizontal, vertical, they are different. This can be, let's say, 100 meters, while this could only be 2. It's completely different, and something else to note is that when the ball hits the ground, the vertical velocity is different than the horizontal velocity. You can think about it like this, okay? When a ball is rolling over, there is no vertical velocity, but there is a 0 and 0, but there is, let's say, 5 meters per second. There is a horizontal velocity. So your horizontal and vertical velocities don't necessarily have to be the same. So we know that v equals vh, and v here equals to v vertical, or vv. And let's look at the horizontal components first. We know that the ball is launched horizontally with an initial velocity of u. So u equals u, h. Let's do that, h. And uv equals 0. Because at here, when the person was holding the ball was not flying up or nor down. Therefore, the initial velocity of going up and down would be 0. And distances, or displacements, if you like to call that, d equals to the horizontal displacement, so sh, and sv equals to h. Okay. And acceleration, we don't know here. However, normally, in questions like these, you can, if they don't explicitly tell you, you can assume that acceleration is, like, this is happening on Earth, and acceleration is gravity, which equals to 9.8. Sometimes the questions might tell you to use 10 as gravity or 9.81 as gravity. However, if it doesn't explicitly say, use the IB's value, which is 9.8. If you go 9.81, it doesn't really matter. The marks team doesn't penalize this. Anyways, so we know that the vertical acceleration is 9.8, and we don't know the horizontal acceleration. Now, one key thing to note is that time is the same. The time it took the ball to travel d distance is the exact same time as the ball to travel h distance. Because if you can pick up anything besides you right now, if you throw it, it wouldn't be flying. Well, it wouldn't be flying when it hit the ground. It's still, when it hits the ground, it goes that height and that distance at the same time. So we know that th equals to t and tv equals to t. Now, what usually comes up is that you would need to link these two to find certain variables. So let's say you only have a horizontal initial velocity and a horizontal distance, and you're asked to find horizontal acceleration, which you clearly cannot because you have two unknowns. You need three knowns and one unknown to find this unknown, okay? Vertically, let's say you have your initial velocity, you have your height, you have your acceleration, but you don't know your time. So with this, you can use these to find t, and you would sub this t in here to go back and find the horizontal acceleration. And yeah, that is projectile motion and how you're supposed to solve it.